All right, in this video, we are going to talk about independent events and the special multiplication rule. All right, so event B is said to be independent of event A if the probability of B given A equals the probability of B. Okay, so in other words, remember this is a conditional probability, the probability of B given A, right? So given A that occurs. If that probability is the same as just the plain old probability of B, right? It's not conditional, then the events A and B are said to be independent. Okay, so what that means is that basically the occurrence of A really has no effect on whether the event B occurs or not. Okay, so if event B is independent of event A, then event A is also independent of event B, right? Um, so generally, what we'll say is that the events are independent events. Two events that are not independent are called dependent events. All right. So the first thing that we're going to do is to look at some events and try to determine whether they are independent or not independent. All right, so let's take a look at example 4.186 from our book. It says the National Center for Health Statistics compiles data on injuries and publishes the information in Vital and Health Statistics. A contingency table for injuries in the United States by circumstance and gender is as follows. Frequencies are in millions. All right, so here is our contingency table. Across the top, we have circumstance. So that's where the injury occurred, at work, home, or some other place. And here is the gender of the person that the injury happened to. So male or female. Okay, so in part A, we want to find the probability that of C1. Okay, so that would be all right. So let me just make it so that I can just draw directly on here. All right, in part A, we want to know what is the probability of C1. All right, so that would just be C1 would mean that the injury happened at work, right? So we would look down here at this marginal number here, 9.3. Remember, those are in millions, so 9.3 million injuries at work, and then the total number of injuries is 61.4. And so I went ahead and calculated that out as 0.151 if you divide those two numbers. Okay. All right. In part B, they want to know what is the probability of C1 given S2. So what is the probability that the injury occurred at the workplace given that the person is a female? Okay, so right, we would basically cross these numbers out and just be looking at the numbers for females. Okay, and so it happened at work, so that'd be 1.3, and then out of the total number of females that had accidents, right, that would be 25.8. So here we're just directly using the table to calculate this conditional probability. We are not using the conditional the conditional probability rule. All right, and that comes out to be 0.050. All right, and part C, they ask us, are the events C1 and S2 independent? So if they're independent, right, that would mean that the probability of C1 given S2 should equal the probability of C1, right? If you go back and look at the definition of what it means to be independent, or two events to be independent, right, that's what it would be. So if we go back here and look, right, two events, or event B is said to be independent of event A if the probability of B given A equals the probability of B, right? So so we're just checking that for this. So we're going to ask, hey, are these equal to each other? Well, the probability of C1 given S2, right, is 0.50, 0.050. And the probability of C1 we calculated as 0.151. All right, and we can see that those two things are not equal. So our conclusion is that C1 and C2, or S2 rather, are dependent. Okay. All right. Next up is part D. In part D, what they want to know is the event that an injured person is male, independent of the event that an injured person was hurt at home. Okay. All right. So S1, right, is male. That the person is male. Let's see. Home is C2, right? The injury occurred at home. They want to know if these things are independent. So one of the things we could do is look at, hey, what is the probability of S1 given C2? And then look at the probability of S1. Okay. So that's one of the things. We could do it the other way too as well if we wanted to. All right. Oops. All right, so let's take a look at these probabilities. Probability of S1, right? All right, S1 is male, right? And so we would look all the way over here. That's 35.6 over 61.4. That comes out to be 0.58. All right, and then the probability of S1 given C2. All right, so in this case, we're given C2, so we would only look at this column over here, right, C2, and then we would calculate, hey, what's the probability of S1? Well, that would be 9.8 over the total for C2, which would be 21.4. And that comes out to be 0.458. Okay. All right, so we calculated this probability to be 0.458. We calculated this probability, probability of S1, to be 0.580. So if these events were independent, then these numbers would be come out to be equal. We can see that they are not equal to each other, right? So S1 and C2 are dependent. Okay, so not independent. All right, so that's it on this one. All right, let's take a look. I think at one more here. Yeah. Okay. Before we go on, let's take a minute and talk about this special multiplication rule. So, the special multiplication rule says that if A and B are independent events, right, then the probability of A and B is equal to the probability of A times the probability of B. Okay. And likewise, if I have a bunch of mutually independent events, right, then if they're all joined by ands, I can just multiply the probabilities together. So this special multiplication rule is easier, right, than the general multiplication rule, but you can't always use it, right? You have to know that the events A and B are independent before you're able to use this one. So you're always going to have to ask yourself, hey, are these events independent? If they are independent, then you're going to use the special multiplication rule, right, which says you just multiply the probabilities together. If the events are dependent, right, then you're going to have to use the general multiplication rule. That's the more difficult one, right, with the conditional probabilities involved. All right, let's take a look at one more example here. All right, so this is 4.188 doctoral degrees. It says the U.S. National Science Foundation publishes data on doctoral degrees conferred in the document Science and Engineering Doctorate Awards. The following joint probability distribution summarizes the doctoral degrees conferred in the social sciences and psychology by gender during 1 year. So we have this contingency table. We have on the top, it's broken down by the field, either social science or psychology, in which the doctorate was awarded. And then over on this side, it's broken down by male and female. And this is a probability distribution, right? So these are probabilities involved here. All right, so we want to find the probability of G1 in part A. All right, in part A, we want to know what is the probability of G1. All right, so it's going to be a marginal probability. That's the probability that the doctorate was awarded to a male. That's over here, 0.419. Part B, or no, still on part A, they want to know what's the probability of F1. F1 was the probability that a randomly selected awardee will be is awarded a doctoral degree in the social sciences, right? So again, that's a marginal probability, 0.582. All right, and then we want to know probability of G1 and F1. All right, so that is a joint probability. So G1 is here, F1 is here, right? So it would be this number right in here. And this is a probability distribution, so it's just that number in there. All right, part B, it says use the special multiplication rule to determine whether the events G1 and F1 are independent. So in part B, right, if G1 and F1 were independent, we would know that the special multiplication rule would hold up, right? So that would mean the probability of G1 and F1 would be equal to the probability of G1 times the probability of F1. All right, and we have all of these probabilities in part A. We know that the probability of G1 and F1, right, is 0.3. The probability of G1, right, we calculated to be 0.419. And the probability of F1 we calculated to be 0.582. All right, and if you multiply these out, right, you will get 0.244. So these are not equal to each other, right? So here we were asking, hey, are these equal, right? And then we have shown, no, they are not equal, right? So that means that G1 and F1 are not independent, they are dependent. All right, so that is another way to determine whether events are independent or dependent. But there are other times when we'll just kind of just think our way through and not compare the numbers. But we definitely can tell if you know the probabilities whether they're independent or dependent these two ways, as in this problem that we worked, where we try to see if it satisfies the special multiplication rule, and the other way where we use the conditional probabilities and compare that to the probability that's not conditional. All right, so I think that is it on this video, and we will separate these other examples out into problems of their own, or videos of their own.